Yeah, good day everyone. In this video, I'm going to show you how to solve indicial equations. Okay, I have up to 3 examples as you can see them on board that I'm going to show you in this video. Okay, now in solving indicial equation like this, you will need to apply two major previous knowledge. Number one, you will need to apply your knowledge of the laws of indices. Okay, majorly when you want to transform this equation, you will have to apply the laws of indices, and after you have transformed it, the result it give you will be, most time it comes in a quadratic equation. Okay, and you know that you will need to apply your knowledge of quadratic equation, solution to quadratic equation. Maybe you want to use completing the square method, maybe you want to use factoring method, maybe you want to use a quadratic formula method in solving such quadratic equation. I would not advise you to use graphical method in this case, because graphical method will take much time. Okay, now let's start with question number one. These are the questions. Now let's start with example number one. So we have solution to all the example now. So example number one is stated as 2 raised to power 2x minus 3 times 2 raised to power x plus 2 equal to 0. Okay, to first and foremost transform this equation. Okay, we want to transform it, and we want to transform it into a quadratic equation, and this we can do by applying the laws of indices, by applying one or more laws of indices. Okay, now, okay, don't forget that this 2 raised to power 2x, going by the laws of indices, going by a certain law, precisely the law that has to do with product of indices. Okay, this 2 raised to power 2x can still be rewritten as 2 raised to power 2, everything in the bracket raised to power x. Okay, which can still be rewritten as, because you know that it doesn't matter the order of arrangement. It doesn't matter the order of arrangement when you are taking product of two entity. It doesn't matter the order of arrangement, you still get the same thing. So it simply means that this thing can still be rewritten as 2 raised to power x, everything raised to power 2. Now, on this note, I would like to urge you to revisit the videos I have made on the laws of indices. Okay, just right below this video, just you check, you will see my channel name, which is Crystal Clear Maths. Click on it, and it will lead you to all the videos I've done, and from it you can be able to lay your hands on the laws of indices, the videos on the laws of indices, and more so the videos on the quadratic equation and solution to quadratic equation. Okay, now this is equal to this. We want to replace this by this now. Why? Because this is what we want. Okay, this is what we want. We want to do something with this. Okay, majorly we want to substitute 2 raised to power x for something else, so that we'll be having this equation to implies that 2 raised to power x into brackets everything raised to power 2 minus 3 times, of course you can still put this into bracket, minus 3 times 2 raised to power x plus 2 equal to 0. Okay, now from here, now we can quickly go and do our transformation. We can do the transformation from here. Okay, by choosing any variable. Let me choose variable v. Okay, and we let v to be equal to 2 raised to power x in this equation. In other words, wherever you see 2 raised to power x, you replace it with v. Okay, and that implies that v raised to power 2 minus 3 times v. Okay, don't forget to replace 2 raised to power x with v. Okay, plus 2 equal to 0. And if you look at this equation very well, this is a quadratic equation. This is a quadratic equation. The next question is that how do we solve this quadratic equation? Okay, the easier way of solving quadratic equation is by factoring method, by factorizing it. So to factorize this equation now, to factorize it, what do we do? Okay, by the way of revision, we ask ourselves what is the factor, or sorry, what are the factors of plus 2 that when added together will give us negative 3. Okay, in other words, minus 1 and minus 2 can give us positive 2. Okay, can give us this. And at the same time, minus 1 plus minus 2 can give us negative 3. So minus 1 and minus 2 are the factors of the positive 2 that can fit in for the factorization of this expression. So therefore, you will go straight and pull down the two brackets, okay? Then the variable v here, then share the factors that we have obtained, share it among, between the brackets, so that you have minus 2. It doesn't matter the order, it doesn't matter the arrangement. You can put minus 1 here and put minus 2 here. You can as well do otherwise, so that you have minus 2 and minus 1. Okay, the next thing, now to the next step, this implies that v minus 2 is equal to 0, or v minus 1 equal to 0, and it implies that v is equals to 2, or v is equal to 1. Okay, that is the values. We have two values realized for v. Okay, so this value we're going to substitute this value for v one after the other into this equation, because don't forget, in the original given equation there is no variable v there. In the original given equation we are dealing with x, so therefore we must, the equation given as the question, we must substitute the value of v back into this assumption. Okay, we must substitute it back into this equation, so that we have to remember that v is equal to what? 2 raised to power x. Okay, you have to remember that v is equal to what? 2 raised to power x. And the same way, this thing can be rewritten as 2x. You are still saying the same thing. 2x is equal to v. Okay, so that wherever you see v, put the value starting with the first value to the second value. Wherever you see v, just put the value of v, so that this implies that 2 raised to power x is equal to what? 2. And don't forget that just 2 is at the same thing as 2 raised to power 1. Okay, so that you just put power 1 here, and since the base at this side is equal to the base at the other side, you cancel one with the other, so that you'll be having x to be equal to 1. Okay, this implies that this equation is true for x equal to 1. In other words, if you take your time to substitute x equal to 1 into this equation, you will see that this side also will be what? Will be equal to 0. So that the equation is true for x equal to 1. Now let's work on the second value of v. Okay, let's work on the second value of v. It implies that this is for v equals to 2. Now for v equal to 1, it implies that this same equation, okay, this same equation implies that 2 raised to power x is equal to what? 1. Because we have replaced v with 1 now, okay, so that you know that 1 can still be rewritten as 2 raised to power 0. You know that 2 raised to power 0 is the same thing as 1, okay? Because why do I choose 2 raised to power 0 to replace 1? I choose it because I'm working towards having the same base at this side as we have at this side, okay? So that I will write this equation to be 2 raised to power x equal to 2 raised to power 0. And since we have the basis to be common, this will cancel this, so that we are left with x equal to 0. This also implies that for this equation is true also for s equal to 0, just as it is true for s equal to 1. If you take your time to check these two values of x, s equal to 0 and s equal to 1, in other words, put x equal to 0 into this equation, everything here will be 0, okay? And if you as well put x equal to 1 into this equation, everything at this side will be equal to 0. So the equation is true for these two values of x. And that is that. So example 2 is stated as 3 raised to power 2x plus 6 multiplied by 3 raised to power x minus 27 equal to 0. Okay? Now, to transform this equation, you must split this power, this indices, split it into its original form, so that 3 raised to power 2x will be rewritten as 3 raised to power x, everything into bracket raised to power 2. I will replace this now by this in this equation. And if I do that, you see that this equation is rewritten as, and if you do that, this equation implies that 3 raised to power x, everything raised to power 2, plus 6 into bracket 3 raised to power x minus 27 equal to 0. Okay? Now to 0. Okay? Choose a variable that we can replace 3 raised to power x with. Let's choose variable t. You can choose any variable so that you let your t to be equal to 3 raised to power x. And by that, the equation is transformed to be t, okay, raised to power 2 plus 6 times t minus 27 equal to 0. And mind you, this is a quadratic equation. Let's look at way of solving it, the method that we can apply. Don't forget that the factoring method is the fastest method. So you can quickly apply it once we can factorize the equation. Okay? Once factorization method can go, you just quickly make use of factorization method. And we can check now by, let's check the factors of minus 27, negative 27. What are the factors of negative 27? That when added together will give you positive 6. Okay? Don't forget that 4. Don't forget that minus 3, negative 3 multiplied by positive 9 will give you negative 27. Okay? And at the same time, negative 3 plus positive 9, that will give you what? Minus 3 plus 9, that will give you positive 6. So therefore, minus 3 and plus 9 are the factors we are looking for. Negative 3 and positive 9. So having done that, just go straight and put down your brackets, the two brackets, okay? Then share the variable t into the bracket followed by the factors you have realized. You have minus 3 and positive 9. Okay, and this implies that that is this bracket times this bracket equal to 0 implies that t minus 3 equal to 0, or t plus 9 equal to 0, which implies that t equal to 3 or t equal to minus 9. Okay, but the equation that we are given in the question, we are given the equation in terms of x, not in terms of t. We just use t here to do our transformation. Therefore, you have to substitute whatsoever value you get for t back into this equation by reminding yourself that t equal to what? 3 raised to the power x, as we have it here. Okay? Now for t equal to 3, so that this equation implies that 3 raised to the power x is equal to 3. And don't forget, 3 is the same thing as 3 raised to the power 1. So you have 3 raised to the power 1 here. Okay? So that since this and this are common, this will cancel this, and you have x equal to 1. Okay? And that is for t equal to 3. Let's check for t equal to 9. Now for t equal to minus 9 rather, for t equal to minus 9, it implies that, this equation implies that 3 raised to power x is equal to minus 9. Okay? So, with this, what are those powers of the 3 that can give us negative 9? There is no any powers of 3 that can give us negative 9. Therefore, for this value, the equation cannot be true. Okay? This equation cannot be true for v. This equation cannot be true for v for t equal to minus 9. 3 is stated as 2 raised to power 2x plus 1 minus 9 multiplied by 2 raised to power x plus 4 equal to 0. Okay? Now, going by the laws of indices, to be precise, the law that has to do with the product of 2 or more common bases. So you can have this to be written as, you can have 2 raised to power 2x plus 1 to be written as 2 raised to power 2x times 2 raised to power 1. Okay? Which can still be written as 2 raised to power x into brackets everything raised to power 2 times 2 raised to power 1. Of course, 2 raised to power 1 is 2. Okay? So that you replace this by this in this equation. And this implies that, 2 into brackets 2 raised to power x, everything raised to power 2. Okay? Minus 9 into bracket 2 raised to power x plus 4 equal to 0. Okay? Now, from here now, we can do our transformation. Let's do the transformation. Let's choose any variable with which we want to do substitution here. Okay? Let's choose any variable. You can choose variable u. Let's choose u. So that you let u to be equal to 2 raised to power x. And this equation will be transformed to 2u raised to power 2 minus 9 times u plus 4 equal to 0. And mind you, this is a quadratic equation. So, how do we go about solving it? How do we go about solving this quadratic equation? How do we go about solving it? Can we factorize it? Let's check if we can factorize it. To factorize this quadratic equation, since the coefficient of u squared is equal to 2, which is greater than 1, we cannot go straight and do the factorization. We have to multiply this and this, which will give us, positive 8u squared. Okay? If you multiply 2u squared by 4, that will give you what? 8u squared. And the next question is that what are those factors of 8u squared that when you add together, when you add them together, they will give you negative 9u. Let's check. 8u squared, when added together, will give us negative 9u. Now let's check those factors. Don't forget that minus 1u multiplied by minus 8u will give you 8u squared. Will give you 8u squared. And at the same time, negative 1u plus negative 8u will give you negative 9u. So can you see that? Or now with this, wherever we see negative 9u in this equation, we replace it by the whole thing here. Okay? Let's do that. Let's do that. So that we have this equation to imply 2u squared minus 9u will be replaced by minus u minus 8u. Okay? Then the 4 we have here plus 4. So everything equal to 0. U into u squared, that will give you 2u. U in minus u, that will be minus 1. Negative 4 in negative 8u, that will be what? 2u. Negative 4 in positive 4, that will be negative 1. Everything equal to 0. If you look very well, we are having two brackets that are common. Okay? Now let's bring together those things that are outside brackets, so that we have the equation to imply. It implies that u minus 4. Then choose one of the common brackets. Everything into bracket. Then open bracket 2u minus 1, close bracket, everything equal to 0. Okay? So that this will imply that u minus 4 equal to 0, or 2u minus 1 equal to 0. And this implies that u equal to 4, or u equal to 1 over 2. But don't forget, we are not looking for u. We only use u to transform this equation. So therefore, you substitute back all this value of u, taking them one after the other into this equation as to get x. Okay? So you have to remind yourself how that you choose u. You choose u to be equal to 2 raised to power x. Now for u equal to 4, it implies that 2 raised to power x equal to 4, which implies that 2 raised to power x equal to 2 raised to power 2. You know 2 raised to power 2 is the same thing as 4. So that this base will cancel this base, and you have your x to be equal to 2. Okay? Now let's do the same thing for u equal to 1 over 2. Don't forget 1 over 2 is the same thing as 2 raised to power minus 1. Okay? Just like a sorry, just like 1 over a is the same thing as a raised to power minus 1. Just like 1 over a raised to power 2 is the same thing as a raised to power minus 2. Okay? And that is negative index. The laws has to do with negative index in the laws of indices. Okay? So that for u equal to this value, it implies that this equation implies that this equation implies that 2x is equal to 2 raised to power minus 1. Or let me put 1 over 2, just as we have it here, which implies that 2x is equal to 2 raised to power minus 1. Okay? And from here, since you have this base and this base to be common, they will cancel out each other. Okay? So that your x will be equal to minus 1. This is another value of x for which this equation is true. Thank you so much for watching this video to the end. Please don't forget to subscribe to, if you have not subscribed to this channel, don't forget to subscribe to this channel. Like and make a comment so that we keep on improving on what we are doing now. Okay? Don't forget to also hit the notification bell so that once I upload any new video, you'll be among the first group of people that will see it. Thank you very much. God bless you.